In this video, we're going to cover descriptive statistics. So let's begin with a definition. Descriptive statistics describes data. It involves organizing data in a way to make meaningful sense of it. It can be used on population data, or sample data. One thing to note about descriptive statistics is what it is not. So I'm going to highlight this in red, make a separate note here. Descriptive statistics does not make conclusions or results about a population. It just describes what we see in the data. So we might describe the population or the sample based on our descriptive statistics, and we'll see ways that we describe our data, but we don't make inferences or conclusions about our population from our data. All right, so what are some of the most common descriptive statistics, and what are some that we will see in this class? So the three main ways that we can describe data is its center, so where the most data occurs, or the middle data, the spread, how far apart the data is from each other, and then the distribution, so what the shape of the data looks like. So let's look at this in a little bit more detail. So the measures of center that we use in this class are, well, there's three that we've already seen. So that is the mean, median, and mode. In this video, we're going to learn more about the spread of data, so how far apart data is from each other. The two measures of spread that we are going to look at is standard deviation and something called the inner quartile range. So I'll write that out. Inner quartile range. And that's often abbreviated IQR. And then another way to describe our data is the shape of the distribution. So we've seen some examples before. So the most common ones are symmetric or skewed, either left or right. But we also see some data that has maybe two modes, two humps where we see data likely to occur. This happens commonly for data like heights or weights. You can think about maybe why that might be. All right, so now that we've talked a little bit about descriptive statistics in general, let's look at some measures of spread. So we haven't focused on this yet, so we'll see some measures of spread and how to compute them. So the first measure of spread that we're going to look at is the standard deviation. Now, it's important to note that this measure is used for symmetric data primarily. What is standard deviation? Well, standard deviation is the difference between, or rather, the difference between one value in a data set and the mean is referred to as the deviation of that data value. So if we let X bar equal our mean, and X is equal to a data value, the deviation of that value is just the difference. Typically, we take an absolute value because we don't care if that difference is positive or negative. We just care about its size. So then the standard deviation, which is the measure we care about, is the average of these distances away from the mean. That is, the standard deviation is, in some sense, the average deviation of all of our data values. So let's get into how we would calculate the standard deviation. So the two ways that we are going to look at how to calculate the standard deviation is by using technology and using the distribution itself. So you can also find a formula for the standard deviation. It involves a lot of different symbols. It's not too complicated, and you can really break it up into steps. But for the purposes of this video, we're going to look at how to use technology to compute it. So first, technology. So you can use a spreadsheet like Excel or Google Sheets, and they have built-in functions to compute the standard deviation for you. The function you use is written here. So you click in your cell after creating your data, and you say equals STDEV parentheses. Inside those parentheses, you're going to select the column of data values. So here is a picture of 2 screenshots of me doing this. So here in Google Spreadsheets, I've just clicked or I've added my data. So suppose my data is 3, 8, 12, 15, 18. So then what you can do is click away from there and click into the box that you want to input or have your standard deviation. When you click in that box, you type in this function here. So you type in equals STD, and it'll actually start to give you some suggestions. One of those will be standard deviation. And then after that parenthesis, you then take your mouse, click, and drag over your data set, and it will populate that cell with this set, in this case, B2 to B6. So these values here represent our data. So it selects the data in those cells. And then you end parenthesis, you press return or enter. And then what will happen is your standard deviation will be filled into that cell. Awesome. Another way we can determine the standard deviation is by looking at the distribution itself. And recall, we measure standard deviation typically when we use symmetric distributions. How do we use a distribution to determine the standard deviation? Well, it's a really awesome rule in statistics that says one standard deviation above and below the mean contains the middle 68% of the data. So you might see this kind of shape a lot. This is the standard distribution or normal distribution. And you'll notice that I have some lines marked in my distribution. So this is no coincidence. The data that we are looking at might be measured in, say, feet, pounds, number of tomatoes. And when we make a distribution, those data values go along that horizontal axis. So let's say we're measuring heights. So here we have feet. So let's suppose our middle value is 5.5 feet. Then we have 6 feet, 6.5, 7, 5, 4.5, etc. Okay. So if we were to identify the middle 68% of this data, it looks about like this. So this is about the middle 68%. And it so happens then that this middle 68% lies within one standard deviation of the center. So that means if I measure here how far away this 5 and this 6 are from the center, that's also going to tell me my standard deviation for my data set. So I can measure, and I have 0.5 between each. So my standard deviation is equal to 0.5 feet in this case. So that's a way that we can read off the standard deviation from the symmetric distribution itself. Okay, so now what if our data is not symmetric? What if it's skewed? So in that case, to measure the spread, we use something called the inner quartile range. What is the inner quartile range? Well, the inner quartile range is the difference between the first and third quartiles. This measurement, this distance, gives us the spread of the middle 50% of the data. Okay, so let's unpack this a little bit. First, what are these first and third quartiles? Let's look with an example. So you might hear quartile and think quarter. Well, you'd be on the right track. So if we have all of our data lined up here, we've seen that the middle value is the median, and that cuts our data into two groups of 50%. We look at the very middle, or the very middle data value splits our data into 50% and 50%. Now we could do this again and split the first half into two chunks and the second half into two chunks. What this has done has divided our data up into 25% or quarters. So that middle of the first half, that is our first quartile, Q1. The middle of the second half of the data is the third quarter of data, and we call it Q3. So in our example, let's determine Q1 and Q3 for the data sets A and B. And the approach is a little different based on if we have odd or even number of values. So let's look at data set A first. So in this case, we have an odd number of values. So what we first do is identify the median. So the median is that middle number, 12. So now to compute Q1, we look at the data values in front of the median, not including the median. That's 3 and 8, and we're going to take the middle value there. Notice that now I don't have a middle value. I only have two values, so there's not one in the middle. So what we have to do is take an average. So Q1 here is going to be between 3 and 8. So it will be 3 plus 8 over 2, which will be 5.5. So that will be Q1. And now moving over to Q3, we look at the same thing, except on the right side. So we look at those data values above the median. We have two of them. We don't have a middle one. So we look at the average between the two. So Q3 here, it's going to be 15 plus 18 over 2, and we get 16.5. Now the process is a little different when we have an even set of data. So we saw in our previous videos that the median for a data set with an even number of terms is going to be the average between the middle two values. So for us, that would be the average of 12 and 15, which is 13.5. So now when we can compute the quartiles, well, Q1, we're just going to look at that left half of the data. We have three values, and we see that we do have a middle value now. So that Q1 is going to be 8. And then looking at Q3, we look at the top half of the data. The middle value is 18. So Q3 is 18. All right, now let's just look at a little bit of language to finish up this discussion on quartiles before we compute the interquartile range. All right, so first of all, the median, we could have called the median the second quartile, or Q2. It is the middle value or 50th percentile. That means 50% of the data are below that value. And similar is true then with the first quartile and the third quartile. In the first quartile, though, often denoted Q1, this is the 25th percentile, and 25% of our data are below that value. And we saw that in our diagram up here. 25% of the data is below Q1. So then what about for Q3? What percentage of the data is below Q3? Well, we have these 3 quarters, so they add up to 75% of the data. So for Q3, or the third quartile, it corresponds to the 75th percentile, and 75% of the data are below that value. Now, these data values that we computed are used often in descriptive statistics. One way they are used is in something called the 5-number summary. The 5-number summary is a list of 5 numbers that include the minimum value of the data set, the Q1, the median, Q3, and the maximum. So it's typically written with parentheses where we start with the min, Q1, the median, Q3, and the maximum. So let's look at that 5-number summary for one of our example data sets. So let's look up here. So I'm going to write out the 5-number summary. So in our case, the minimum is 3, Q1 is 8, the median is 13.5, Q3 is 18, and the maximum is 20. So the 5-number summary is just a nice succinct way to describe both the min, the max, the quartiles, and the median. And then next we have something called a range. So a range just describes the distance between the min and the maximum values of our data set. It's not a good measure of spread because it's very influenced by outliers, but it does tell us some information about where we can expect or how far away our data values are, or where we can expect to find our data, rather. But what we can use to measure the spread is the interquartile range, which is that concept that we started with. The interquartile range is just the difference between the Q3 and Q1. In particular, it tells us where the middle 50% of the data is, or the spread of that middle 50%. So let's look at the example up here. So in this case, the IQR is just going to be equal to, again, Q3 minus Q1. So for us, that would be 18 minus 8, which is equal to 10. All right, so just to summarize, in this video on descriptive statistics, we summarize the main measures that we use in descriptive statistics, and they are the center of the data, the spread of the data, and the distribution of the data. We've seen previously more details on the center. So in this video in particular, we focused on the spread of the data. We looked at 2 ways of measuring spread. For symmetric data, we looked at the standard deviation. And for skewed data, we looked at interquartile range. It should be noted that this interquartile range can be used for symmetric data as well. But typically, if we are in the skewed case, we are going to use this IQR instead of the standard deviation. All right, thank you so much for watching.